my physics professor in college. He liked gas clouds between stars. Yeah, okay. Everybody likes gas clouds between stars. He studied the behavior of the nuclei among the atoms in those gas clouds. And he hypothesized that in the presence of a strong magnetic field, that it would deflect radio waves that came by. He discovered the principle of physics called nuclear magnetic resonance as applied to the universe. Then a clever engineer said, wait a minute, if you can find out what kind of atom, because the nucleus is the identity of the atom, if you know what kind of atoms are out there by this method, maybe I can make a machine down here, and I can put you in the machine, and I can find out what kind of atoms are moving around your body. His discovery, which was awarded the Nobel Prize, became the magnetic resonance imager in every major hospital in the land today. Was he thinking about health? No. No. In fact, every machine in a hospital with an on-off switch that is brought into the service of diagnosing the health of your body is based on a principle of physics discovered by a physicist who had no interest in your health. When Einstein wrote down his equation for the stimulated emission of radiation, which is the foundation of the laser, was he thinking to himself, barcodes? Don't ever tell me, why are you studying this? How is it helping me? You know, I don't know how it's going to help you. I have no idea. Neither did Faraday. He just knew you would tax it. Neither did Einstein. Neither did anybody who made great discoveries about our understanding and our relationship to nature. Do you know, who here remembers statistics? The method of least squares to put a line through points? That was discovered by Gauss, a mathematician, who applied it to the orbit of the first ever discovered asteroid. The asteroid went behind the sun, it's in the glare, you can't find it. He says, well, did this over here, look over here in 4 weeks. There was no methods to figure that out. He invented a new kind of math to do that. He was inspired by space. If I had an oven with coal, like a Franklin stove, which runs on wood, and I say, I give you too much. I'll give you $1 million. Make me a better stove. And you're an expert in heat transfer and thermodynamics, and you know you're good. All right? And so you design an oven that's insulated and is temperature controlled and self-regulating. No matter how much time I give you, and no matter how much money I give you, you will never invent a microwave oven. Because that came from military research and communications with microwaves. And we kind of stumbled on the effect of microwaves on food, because water is a major ingredient of food, and microwaves tickle the water molecule, rendering it hot. And then someone said, hey, if it does that to water, it'll do that to my food. Let's make a cavity and call it a microwave oven. So here's the task. I stand up in front of a class of 8th graders, and I say, who wants to be an aerospace engineer so that you can design an airplane that's 10% more fuel efficient than the one your parents flew? There's some people who will require that of me as I stand up in front of that class. Instead, what I want to say is, who wants to be an aerospace engineer so that you can design the airfoil that will navigate the rarefied atmosphere of Mars? Everybody's standing up. Everybody wants to do that. We're a free country. You can't require people to do anything, but you can inspire them to completely rise to their intellectual and academic potential. Without that carrot, we will wither on the vine. It's not good enough just to have a good science teacher. You need something at the end of that pipeline when you're hatched out of the educational system. Now what do you do?